Welcome to Physiology class. The topic of discussion for this session is electrocardiography or ECG. Moving on to the definition, ECG refers to the extracellular recording of summed up electrical events of all the cardiac muscle fibers generated with each heartbeat. That is, during each heartbeat, the electrical events that are generated by the entire cardiac muscle fibers are recorded in ECG. It is a graphical record of electrical events and is obtained by placing electrodes on the surface of the body, that is, on the limbs and on the chest. And then it records the voltage difference generated by the heart. This is a machine which is used to record ECG called the electrocardiograph. Now, why is this ECG assist? The uses of ECG includes to know the anatomical orientation of the heart, to check the disturbances of rhythm and conduction, to detect the ischemia of myocardium if present, to assess the location, extent and progress of myocardial infarction if present, to know the relative size of the chambers, to check the influence of certain drugs, to know the effect of altered electrolyte concentration, and to assess the efficiency of electronic pacemaker function. So these are the uses of assessing ECG. Now let's discuss about the ECG leads. ECG lead is a pair of electrode used to detect the potential difference generated by the heart. These ECG leads are broadly categorized into two, and they are direct leads and indirect lead. When the lead is directly applied over the surface of the heart, that is called direct lead. That is, it is used only during the cardiothoracic surgery and all. And the next one is indirect lead, where the leads are applied on the surface of the body to record the cardiac activities. That is the one that is used for assessing ECG. Therefore, it is the indirect lead which is used in assessing ECG. And these indirect leads are further categorized into two, and they are unipolar leads and bipolar leads. In unipolar leads, one electrode is active and the other is an indifferent electrode at zero potential. In bipolar leads, both the electrodes will be active and one of the active electrodes is connected to the negative terminal and the other one will be connected to the positive terminal. So usually a 12-lead recording is performed for the complete analysis of ECG. Now let's discuss about the bipolar limb leads used for assessing ECG. There are three bipolar standard limb leads designated as lead 1, lead 2 and lead 3. It is selected by a scientist called Einthoven to record the electrical potential on the frontal plane. And this is called Einthoven's triangle. That is, it is an equilateral triangle with each side representing the axis of one of the bipolar limb leads. It is an inverted triangle with its apex pointing towards the groin and the base between the two shoulders. So according to this, a law is there which is called Einthoven's law. And the Einthoven's law states that if the ECGs are recorded simultaneously with three leads, that is using lead 1, 2 and 3, the sum of the potentials recorded in lead 1 and lead 3 will be equal to the potential generated in lead 2. That is called Einthoven's triangle. Now let's see where these leads are placed. The lead 1 records the potential difference between the right arm and the left arm. Lead 2 records the potential difference between the right arm and left leg. So this is something which is extended towards the left leg. Now the next one is lead 3, which records the potential difference between left arm and left leg. So these are the three bipolar limb leads used in assessing ECG. The next one is chest leads. Chest leads are otherwise called precordial leads, which lies on the transverse plane. There are 6 unipolar chest leads designated from V1 to V6. And here you can see the location of the chest leads being placed over the chest. This is V1. It is placed in the right fourth intercostal space near the sternum. This is V2, which is placed in the left fourth intercostal space near the sternum. Then comes V3. It lies between V2 and V4. And this is V4, which is placed in the left fifth intercostal space at the mid-clavicular line. This is the mid-clavicular line. Then comes V5, which is placed in the left fifth intercostal space at the anterior axillary line. And the last chest lead is V6, which is placed in the left fifth intercostal space at the mid-axillary line. So this is the location of placing chest leads, unipolar chest leads. Now let's discuss how the normal ECG will be. The ECG is recorded on a millimeter square graph paper moving at the speed of 25 millimeter per second. The x-axis represents time where 1 millimeter is equal to 0.04 seconds. Y-axis represents voltage where 1 millimeter is equal to 0.1 millivolt. So any deflection of the record above the baseline is regarded as positive deflection, and any deflection of the record below the baseline is regarded as or considered to be the negative deflection. And if there is no deflection from the baseline, then that is regarded as isoelectric line. So this is a normal ECG where you can see this is the x-axis representing time, the y-axis representing voltage, and this is the isoelectric line where there is no deflection. And if there is any deflection from the isoelectric line, see here you can see this, and this is another one that is called positive deflection. And if there is any deflection below the baseline, here you can see that, and they are called negative deflection. So this is the isoelectric line, this is the positive deflection, and this is the negative deflection. This is x-axis, this is y-axis, and this is recorded on a millimeter square graph paper moving at a speed of 25 millimeter per second. So this is a typical ECG. Now let's discuss about the waves of ECG. The first one is P wave. So P wave is the first rounded positive deflection. Here you can see this is a normal ECG, and P wave is the first rounded positive deflection. It is caused by the depolarization of atrial musculature. That is, it is a depolarization of atria which is responsible for the production of this P wave. Its duration is around 0.1 second, and its amplitude ranges from 0.1 to 0.12 millivolt. Now let's see the clinical significance of this P wave. As I've already mentioned, P wave is produced by the depolarization of atria, and therefore magnitude of P wave is a guide to the functional activity of atria. In mitral stenosis, that is whenever there is narrowing in the mitral valve, this P waves become large and prolonged. This P wave becomes large and prolonged. In tricuspid stenosis, that is whenever there is a narrowing in the tricuspid valve, what happens to this P wave is it becomes peaked. It becomes tall and peaked. In atrial fibrillation, this P wave disappears and is replaced by fine regular oscillations. And when the cardiac impulse arises from an ectopic pacemaker, that is the impulse being generated apart from SA node. So in the case of ectopic pacemaker, this P wave is altered or inverted. I repeat, the clinical significances of P waves are, in the case of mitral stenosis, the P wave becomes large and prolonged. In tricuspid stenosis, the P waves become tall and peaked. In atrial fibrillation, the P wave disappears and is replaced by fine regular oscillations. And in the case of the conduction being generating from an ectopic pacemaker, the P wave will be either inverted or altered. So that is all about P wave. Now let's discuss about QRS complex. So this is the QRS complex. It consists of three consecutive waves and they are Q wave, R wave and S wave. The Q wave is the initial negative deflection in QRS complex. R wave is the positive deflection in QRS complex and S wave is the second negative deflection in the QRS complex. Now, what is the cause of QRS complex? It is caused due to the ventricular repolarization. It is the ventricular repolarization which is responsible for the production of QRS complex. Its duration is less than 0.08 seconds. Now, let's see the clinical significance. This is a normal Q wave, and whenever there is any deepening of Q wave, that is deep Q wave along with other changes, is an important sign of myocardial infarction. So deepening of Q wave is an indicator of myocardial infarction. Then the tall R wave is seen in ventricular hypertrophy. The length of the R wave will be much more elevated in the case of ventricular hypertrophy. The voltage of QRS complex will be low in hypothyroidism and pericardial effusion. And this QRS complex is prolonged. The QRS complex is prolonged in bundle branch block. So these are the clinical significances of QRS complex. I repeat, QRS complex is produced by the ventricular repolarization. Deepening of Q wave is an indicator of myocardial infarction. Tall R wave is seen in ventricular hypertrophy. The voltage of QRS complex is prolonged in bundle branch block and the low voltage is usually observed in hypothyroidism and pericardial effusion. Then comes T wave. T wave is the last positive dome-shaped deflection of ECG. The cause of T wave is ventricular repolarization. I repeat, P wave is caused by atrial depolarization, QRS complex is caused by ventricular depolarization, and T wave is caused by ventricular repolarization. The duration is 0.27 seconds. The duration of T wave is 0.27 seconds. Now let's see the clinical significances. In old age, this T wave is usually flattened. Then in hyperkalemia, that is whenever the potassium concentration gets elevated, tall and peak T wave can be observed. Exercise increases the amplitude of T wave in healthy hearts. An inverted T wave is an indicator of myocardial infarction. I repeat, in old age, this T wave is flattened. Tall and peak T wave is an indicator of hyperkalemia. Exercise increases the amplitude of T wave in healthy heart. An inverted T wave is an indicator of myocardial infarction. So that is all about T wave. And the last wave is U wave. U wave is a small rounded positive deflection. It is caused due to the repolarization of papillary muscles. Repolarization of papillary muscle. Its duration is of 0.08 seconds. And this U wave is rarely seen normally and it becomes prominent in hypokalemia. That is whenever there will be reduction in the potassium concentration. It becomes more prominent. So that is all about U wave. I repeat, it is caused due to the repolarization of papillary muscle and it is rarely seen normally and becomes prominent in hypokalemia. So that is all about the waves of ECG. That is P wave, QRS complex, T wave and U wave. Now let's discuss about the intervals. The first one is PR interval. It is measured from the onset of P wave to the end of QRS complex. To the onset of QRS complex. I repeat, PR interval is measured from the onset of P wave to the onset of QRS complex. It measures AV conduction, that is atrioventricular conduction, including the AV nodal delay. Then comes QT interval. This is QT interval. It is the time taken from the start of QRS complex to the end of T wave. I repeat, it is measured from the onset of QRS complex to the end of T wave. It indicates the total systolic time of ventricles. That is, it includes ventricular depolarization and repolarization. So these are the two intervals, PR interval and QT interval. Now let's discuss about the segments of ECG. The first one is PR segment. PR segment lies between the end of P wave to the beginning of QRS complex. That is between the end of P wave to the beginning of QRS complex. Then comes ST segment. It is an isoelectric period between the end of QRS complex and the beginning of T wave. From the end of QRS complex to the beginning of T wave is the ST segment. So that is all about the waves and segments of ECG. So if ECG is asked as a short essay, first you have to write the definition, then you have to enlist the uses of ECG, then you have to draw a typical ECG along with the waves, intervals and segments, and then you have to describe each wave, each interval and each segment in detail. There is P wave, QRS complex, T wave, U wave, and then the intervals along with segments. So that is all about ECG. I hope the concept is clear. Thank you.